Shake Table Lab by Sarah Ramos and Michelle Key. Before we started building, we used an app called Sketch to plan out the dimensions of our building. We decided that the whole building height would be 2 straws tall. 2 straws are equal to 36 centimeters. We also decided that the bottom would be 1 straw across, which is equal to 18 centimeters. Michelle and I started building the base and the walls. Then we connected straws to the cardboard to make it sturdier base. Then we connected the upright straws to the base we had made, trying to make the structure sturdier. We decided that putting straws in an X shape around the building would hold it together so it wouldn't fall as easily. Also, we put a support in the middle. Then we installed supports inside the tower. We also applied the floors. After putting all the supports on, we decorated the roof. We cut colorful paper and made a peacock for the top. First, we created a sketch of our building and put the height of the building. The first floor was supposed to be 19 centimeters, but it was actually 19.05 centimeters. The second floor was supposed to be 19 centimeters also, but it was 20.32 centimeters. When static testing, we made sure our building was strong by putting weight on the structure. We found out that it could hold weight without collapsing. Putting straws in an X shape made the building stronger, and putting supports in the middle also supported the building. The strongest part is probably the first floor because it had the most supports. The weakest part was the top because it didn't have supports at all. We used tape to put together straws and to tape the top on. We also used construction paper. We used it for doing the top and decorating. We started off with only 4 sandbags. Then we added more sandbags and made the earthquake more intense.
First major earthquake.
It's not even moving.
Yeah.
I know.
Yeah.
It's recording the whole entire thing.
Oh, it's shaking.
Yeah, there's a moving.
Oh, it's flexing right there.
No! After a while, our building collapsed. It collapsed at 18 sandbags.
It's gonna live.
It's blurry.
Oh, it's dead right there.
Yes!
We used a computer to graph the movement of our tower. The X represents the side-to-side motion. The Y-axis is forward and back, and the Z-axis is up and down. Michelle and I interviewed each other. We talked about how we could improve and what we did well. First, Michelle interviewed me. Our building supported 16 sandbags. It collapsed at the lower X's because they weren't strong enough to hold the sandbags. I think if I did this project again, I'd probably make the X's like 2 straws wide. I learned that the towers most often break at the X's at the bottom part. I liked to try and find different strategies to make the building stronger. I also liked watching our towers collapse, even though it was like nerve-wracking. After, I interviewed Michelle, and she told us a little bit about what she thought we did well and what we had to improve on.
I think we built our tower really good because it holded 16 sandbags. Our building failed at the crossbars because they weren't strong enough to hold some of the weight on the side. If I could make any changes to the building, I would try to make my best to make the crossbars more stronger and add another straw to the middle pole so it'll have more strength. I learned that it's really hard to make an earthquake-proof building because you must know where to put the poles and if your crossbars are strong enough to hold the weight. I enjoy building the tower, decorating it, and watching it fall.